Okay, good morning, students. So I think I'm audible. So let me. Some noise is there. Okay, let me share. Okay, so last
Sir,
time.
the noise is still coming.
Uh, yeah, actually. Okay, let me just. Okay, am I audible?
Yes, sir.
Okay. Okay, I think now noise is not there. Okay, so last time we have studying using generator base here, continuous time Markov chain. So then we have obtained that Kolmogorov-Chapman equations are Pt plus S is Pt plus into Ps. Then forward equations P prime T is PTQ and backward equation is QPT. So therefore the solution is PT is equal to P naught e raised to power QT. Now let us doing this example. We are doing this example. Consider continuous time Markov chain xt having states 0 and 1 whose infinitesimal matrix, that is generator, is Q. So therefore clearly V naught is alpha, V1 is beta, and Q01 is alpha, Q10 is beta. So therefore P01 is 1 because Q01 is V0 into P01 and Q10 is V1 into P10. So therefore this is the. So now we want to find out the PT, basically the transition probability matrix. Okay, so for that we know that solution is PT is e raised to power QT, which is nothing but this summation, and derivative is basically this. Okay, so let us first of all determine the eigenvalues of matrix Q. So first we determine determinant of Q minus k times I. So therefore this is I is 1001. So therefore this is minus alpha minus k alpha beta minus beta minus k. So this is equal to k plus alpha k plus beta minus alpha beta, which is uh, this is k times alpha plus beta plus k. So that we put equal to 0. So which implies that k1 is 0 and value of k basically is 0 and minus alpha minus beta. So the matrix can you say is diagnosable? We have distinct eigenvalue. So whether matrix is diagnosable? Yes, the matrix is diagnosable because the property of diagnosable matrix that a matrix of order is diagnosable if it has a distinct eigenvalue. So that is one property. So the matrix Q is diagnosable. So therefore Q can be written as U D U inverse, where D is the diagonal matrix, that is having diagonal elements, other elements are 0, and U is non-singular matrix. Okay, so D here is K1 0 0 K2. That means 0 0 0 0 minus alpha minus beta. So therefore Et that we know is e raised to power qt, which is summation k is greater than b, t raised to power q raised to power k upon k factorial. So therefore this is summation t raised to power k factorial u d k u inverse q raised to power k. Okay, then this will be some u summation t raised to power k factorial dk u inverse. So therefore this is u e raised to power t d u inverse So therefore this value is u. Now we know that k1 is 0. So therefore this value is 1. Next value is also 0, but we take this 0 value here. So then this will be 0 and this is 0. And when k2 is minus alpha minus beta, therefore this becomes e raised to power minus t alpha plus beta u inverse. So this is the value. So if alpha beta is equal to 0, then pt is I. Otherwise, it's each entry follow the sum term E I J T, which is some just plugging in the value u and u inverse and then multiplying. So clearly you can say that the elements are Aij plus Bij e raised to power minus alpha plus beta t. So to determine this Aij
Hello, sir.
and Bi,
Sir,
yes,
sir, how have you written e to the power tt?
because that is expansion basically, just a notation. Meaning is this, just a notation.
Yes, sir. So in the next step, sir, like uh, and like how have you put the values like e to the power minus t alpha plus beta 1 and 0 0
First
these
of all,
values?
then this is 0. D value is basically this 0 basically. This value, this value. Then this
Yes,
is
sir.
0. This is 0. And then this is minus alpha minus beta. Then this summation will be e raised to power minus t alpha plus beta, expansion of that. And when this is 0, k1 is 0. In that case, this is e raised to power some 0, which is
Okay, sir.
1. Is it okay?
Yes, sir.
So now Pij is this. And how to determine this Aij and Bijs? So for that, we will use this. So when our Pij 0 is I, that means this is where Eij Eij 0 is Aij plus Bij, which is equal to delta Ij, because this is I. So that means ijth element is delta Ij. Delta Ij means when I is equal to j, this is 1. When I is not equal to j, this is 0. Also, this derivative So you are taking the derivative, so you will getting minus alpha plus beta bij into e raised to power 0 because t is 0. Okay. Then this is capital Q, but this means that the ijth element is qij. That means this Q has elements qij basically. So for example, if I want to find A11 plus B11, which is delta 11, which is 1, and minus alpha plus beta B11 is Q11. But Q11 you can say is, okay, basically I'm taking minus beta okay, or you can take, let us say 0 0, that is also one b0 0, this is Q00, which is Q0 minus alpha minus alpha. So solve this. So you are getting B00 as alpha upon alpha plus beta. So therefore A00 is beta upon alpha plus beta. So PT is how much? This is A00 because this is P00T. P01T, P10T, P11T. Okay, so this will be beta upon alpha plus beta. This is A0 plus B00 e raised to power minus alpha plus beta t from here. In the same fashion, you can find the other values as I'm saying for A11, B11, and so on. All the equation you can write. So this will be alpha plus beta minus alpha plus beta e raised to power minus alpha plus beta t beta upon alpha plus beta minus beta alpha plus beta e raised to power 9 alpha plus beta t alpha upon alpha plus beta plus beta alpha plus beta e raised to power minus alpha beta t. So this is PT. So these are transition probabilities. That means, for example, this value is probability. If xt is the continuous time Markov chain, then xt plus s is equal to 1 given x naught is equal to 0. For example, this value. Okay, so these are the transition probability. So can anyone tell as what is the limiting values? Limiting probabilities or steady state probability? So what we have to do?
Sir, limit t times infinity.
Yeah, sorry. So clearly as t tends to infinity, limiting probabilities are beta upon alpha plus beta, alpha upon alpha plus beta, beta upon alpha plus beta, alpha upon alpha plus beta. So this is the value. So also you can verify using pi q is equal to pi. Because that becomes independent of the initial state. And so that means it is in state 0 with probability beta upon alpha plus beta. It is in state 1 with probability alpha upon alpha plus beta. Okay, so that is the value. Also, the equation in terms of generator is pi q is equal to 0, summation pi j is equal to 1. So just verification you can do using this. Pi q is equal to 0, summation pi j is equal to 1. So pi j values are pi naught here is beta upon alpha plus beta, pi 1 here is alpha upon alpha plus beta. So you can say this. Pi naught, pi naught, pi 1, pi 1. Any question here? Let us take another example. So just q is if minus here half, half, 1, minus 2, 1, 0, 1, minus 1. So what are the eigenvalues? You can check. Eigenvalues are k1 is 0 and k2 is minus 2 minus 1 by and k3 is minus 2 plus 1 by under root. So we have repeated roots here. So if you solve this equation, so you know that using the linear algebra, this will be Eijt is Aij plus Bij e raised to power minus 2 minus 1 root 2 t plus Cij e raised to power minus 2 plus 1 root 2. So this is the value. Where Ij, let us say 1, 2, 3. So what are the equations? Because P0 is I, that means Aij plus Bij plus Cij is delta Ij. Also, derivative of Pt at t is equal to 0 is q. So from here you will get minus Bij 2 minus 1 by under root 2 minus Cij 2 plus 1 by under root 2. This is Qij. Qij means elements of Q, ijth element. And similarly, T square Pt at t is equal to 0 is Q square. That means not Q square, but ijth element of Q square. Okay, so this will be, take the second derivative, put t is equal to 0. Take Q square and ijth element of Q square is Qij2. So similarly, you have here roots are basically plus and minus. If roots are repeated, let us say in the example, the determinant of q minus k times I is 0. Roots are 0, minus 2, minus 3, minus 3. Here repeats are repeated. Then Pt is just about Qt or Q. So Pij, T will come out to be Aij plus Bij, e raised to power minus 2t plus Cij, Bij t e raised to power minus 3t I j r 1 2 3 4. Then you use same thing, p0 is I and dn upon dt is qn. Okay, so any question? So here we have learned how to find out the transition probabilities if generator is with us. So any question till now? Okay, am I audible?
Yes, sir.
Okay. So let us take an example. A machine repair model. Consider a job shop that consists of M machines and one serviceman. Suppose that the amount of time each machine runs before breaking down is exponentially distributed with mean 1 by lambda, and suppose that the amount of time it takes for the serviceman to fix a machine is exponentially distributed with the mean 1 by mu. What is the average number of machines not in use. So we have M machines and one serviceman. What was the amount of time each machine runs before breaking down is exponentially distributed with mean 1 by lambda, and serviceman fix the machine is exponentially distributed with mean 1 by mu. Okay, so what is the average number of machines not in use? So let us define xt is equal to n. That means system is in state n whenever n machines are not in use. We want to use this. So if n machines are not in use, so how many machines are in use? M minus n. So that is M minus n machines is in use. Okay, so because exponentially distributed, so let us say n minus n, n, n plus 1. It is lambda minus 1, lambda n. This is mu n, mu n plus 1. So clearly, this is a birth and death process. Because each machine is breaking down with the mean 1 by lambda, and repairman is service serving machine with the rate 1 by mu. So lambda n machines not in use. Okay, that means m minus in use. N plus 1 means n plus 1 machines not in use. That means from n to n plus 1 state we are going, one machine is breaking down. So that means m minus machines are there in state n. Each is exponentially breaking down. So what is the rate? M minus n lambda, as we are already doing these kind of things. Minimum of x1, x2, x m minus n. Each is exponential with the rate lambda. So minimum is exponential with the rate m minus n lambda. And mu n, that means here n machines not in use. That means m minus n machines is in use. Here, one machine is repaired. N minus N means M minus N plus one machine is in use. So therefore, one machine is repaired. So therefore, only one serviceman is there. So therefore, it is repairing with the rate mu, because mean is 1 by mu. Therefore, this is mu. And is greater than 1. Yes, any question till now? Okay, so can anyone tell how to find solutions, limiting probabilities or steady state probabilities in birth and death process?
Cn into P0.
Yes, good. So that means in birth and death process, our P naught is 1 by S. So where S is 1 plus C1 plus C1 plus C2 plus so on, where Cn is this, and Pn is Cn P naught. Okay, so this is the solution. So Pn is the probability that n machines not in use. So P naught is 1 by S, which is 1 plus C1 plus C2 plus so on. So this is 1 plus summation, and is from 1 to M, because after M lambda n is 0. Lambda naught, because Cn is lambda naught, lambda 1, lambda n minus 1, mu1, mu2, mu1. This is C naught. So lambda naught is M lambda, lambda 1 and minus 1 lambda, and then M minus n plus 1 lambda upon mu raised to power n. Okay, so therefore this will be 1 by 1 plus summation lambda by mu raised to power n m factorial upon m minus n factorial. Also, Pn is Cn P naught. So Cn is lambda by mu raised to power n m factorial m minus n factorial upon, because P naught is this value, n is from 1 m lambda by mu raised to power n m factorial upon m minus n factorial, where n is from 0, 1, 2, m, other values are 0. So therefore, average number of machines not in use is summation n Pn. N is from 0 to n. So any question till now? So this was about continuous time Markov chain. So also we have seen the MM1 or MMC queuing system are particular examples of birth and death process. Okay, so next time we will start with the queuing theory. So there we will study MM1, MMC, MMCC, MM1K, MM infinity queuing systems. So any question till now?